All right, example 3. Now here we're going to solve 2 secant squared x minus tan to the fourth x equals a negative 1 for all real values of x. So if we happen to get to, and it says all reals again, so if we happen to get to like a imaginary number at the very end, something is wrong. We need to also go back and either check that we did the work right, or just to see that if it is an imaginary number, that's not part of our solution. But it says for all real values, because they want to know the real value answers. All right, so we're going to take a look at this function, 2 secant squared x minus tan to the fourth x equals a negative 1. And we're going to solve this out for pretty much x. Find all those x values that work for this. Now, remember back to what we've done for the other, examples. We've changed these either to all sines, all cosines, or some of that sort, so that we're dealing with just like one trig function or just 2 trig functions here. And so what's the best bet to do is always see if we can change one of these trig functions to the other trig function using one of our identities, and then get the whole thing equal to 0. So if you remember back from our Pythagorean identities, we know that secant squared x is equal to 1 plus tan squared x. So if that is true, that means we can substitute in here and then get all the tangents and then work it out from there. So that's what we're going to do. I'm going to change this from secant to tan squared. So we're going to do 2 times 1 plus tan squared x minus tan to the fourth x equals a negative 1. I'm going to erase this down because you already have that identity. We're going to do distributive property here. So that's 2 plus 2 tan squared x minus tan to the fourth x equals a negative 1. Once again, trying to get this equal to 0, so we add 1 to both sides. That goes to 0 on this side. This goes to 3. That equal to 0 there. And I'm going to go ahead and put this in descending order for the exponents. So we have a negative tan to the fourth x plus 2 tan squared x plus 3 equals 0. And to keep it from getting awkward and weird at the end or towards the end, we're going to divide each one of these terms by negative 1 so that we're dealing with a positive leading coefficient, or a positive leading term. So here, that would give us a positive tan to the fourth x minus 2 tan squared x minus 3 equals 0. All right, with that being said, we're going to go ahead and try to factor this thing down. And so I'm going to spend a little bit of time on this. I'm going to make it into this little box over here. And we're going to use what we do here in this little box to help us solve this whole thing out here, this trig function. So what we can do is we can make this thing into an algebraic expression. X to the fourth minus 2x squared minus 3 equals 0. Now, this next thing is going to be able to happen only if we have these things going on. If we take that middle term there, the x squared, if we square that and get that first term here, this will work. If we have x cubed and we square that and get x to the sixth, this will work. If we have x there and we square that x and get x squared, this will work. For anything that we take that middle term here, that variable, and square that and get that first term, what we're getting ready to do will work. But if it does not, if this is like x to the third and this is x to the fourth, that won't happen because we square x to the cube, x cubed, we square that, that'll be x to the sixth. And if we're done with x to the fourth, you can't do it. So this must happen as if we take that middle term and square it and get that first term, we can do it. It must happen in that order. If not, then you have to find another way of doing it. All right, so with this one, we're going to go ahead and look at our x like we've done before. Or if you're in Mr. G's class, you do the t. Look at, okay, if we do -3, so the understood 1 here times -3 gets you -3. In the middle, get -2. So once again, -3 here and -2 here. So we're looking at what times what, and that's horrible looking. So let's fix that. We have 3 and -2. So we're looking at what times what would give us a -3. When we add those same two numbers together, we give us a -2. And same thing will be here. What times what gives us -3, and we add those same two numbers together, it gives us a -2. I'm going to shorten this down because we don't need that much space. So if we look at it, we know, okay, this is -3, this would be +1. Multiply those together. That gives us -3. If we add those two together, that gives a -2. So same thing works out. So normally we would say, if this was like x, there's an x here and an x squared here. Normally we would put x minus 3, and then x plus 1. We say that equals 0. And then we solve it out from there. But in this case, because we're dealing with an x squared term here instead of x, these will be x's, x squares. So that when we multiply it out, multiply x squared times x squared gets us x to the 4th, like we said we're looking for. And then if we continue on multiplying it out, it goes back this here. So we have to use x squareds here instead of just regular x's. And then from that point, we went on and solved it out. So that gives us x squared equals 3, x squared equals a -1. Hit the square root of both sides. It gives us x equals plus or minus square root of 3. And take square root of that. That will give us x equals plus or minus I. Because square root of a negative number is an I. So that's imaginary. And just remember back what we said earlier, it must be real numbers, not imaginary numbers. So when we get down, when we look at this part, this will be, we can't use it. So when we get to that, when we do that for our tangent itself, we won't be able to use that part there. So let's go ahead and go back to our tangent information, and we're going to use the same thing we did here to solve for tangent. Okay, so with that being said, I'm going to rewrite this as 10 to the 4th x minus 2 tan squared x minus 3 equals 0. We're going to go ahead and break it down just like we did here, so we can actually jump straight to this point because we already worked out the information here. So we can break it down to tan squared x minus 3 times tan squared x plus 1 so equal 0. And then just like we did here, we broke them up, we set them both equal to 0 and we solved them out. And then we solve it out. So we add 3 to both sides. So we're looking at tan squared x equals a positive 3. Add -1 to the other side. So tan squared x equals -1. And with this, we don't know, because we've never dealt with tan squared values. We've only dealt with tangent values. So if that's the only thing we've dealt with, then we take square root just like we did here. Take the square root of both sides. And we get tan squared x equals plus, sorry, not tan squared, just tangent, sorry. So tangent x equals the plus or minus square root of 3. But then for the other side, we take the square root of both sides here. That would be tan x equals a plus or minus I. Now, once again, we're looking for real values, and there's never a point that we have tangent equaling an imaginary number, because we're looking for real values. So for this one, we go and cancel that out because there are no real values here. But for the other one, we need to find out where are all the square roots of 3's, and then also where are all the negative square roots of 3's. So I'm going to go ahead and close this box off because we're done with it. And it helped us solve this out. And I'll tell you and I guarantee you that if you understand how to solve it algebraically, you can solve it trigonometrically. So I'm going to rewrite this over here, and we'll break it apart. I'm going to look at 10x equals square root of 3. We're looking at 10x equals a negative square root of 3. Now from our chart and our table, we have to figure out what values will give us square root of 3, what values will give us negative square root of 3. And with this one, it doesn't necessarily tell us to use radians or degrees, but I would tell you, I want you to do radians. So this is what we're going to do this in radians because I think it'll make you think more and remind you more of the values there. So we're going to look at where the square root of 3 is for tangents from all the times we have in our chart. And we're going to deal with the positive ones first. So we have pi over 3 for 1. And the next one would be where? Where would the next one be? Where would the next one be? Where would the next one be? You have to say 4 pi over 3. That would be the next time that you would see that. So it's not 2 pi yet, but it's the next one. All right, so the next one, as you would notice later on, would be 7 pi over 3, and then so on and so forth. So what we have to figure out, okay, we have our values here of where there's going to be square root of 3, but those are just for this little part here, this partial part here. This is not for every single value for x. So we have to find out where that is. So what we're going to have to do is find out, to get from here to here, what do we have to add? To get from here to here, what do we have to add? And if you think about it, if you add pi to it, we would be able to get this next term. So if we add pi here, which means that we would have to get common denominators, which would be 3, so multiply the bottom by 3, multiply the top by 3. You add those two 3's together with that 1, they give us 4. And then so on and so forth. So if we add pi to it, then that means we will get every value that we need. So if we were to start off with pi over 3, and then we would add pi to that, and then we're going to put a k there for every value, every interval. Sorry. And we're going to say k is an integer. That would satisfy this whole thing here for the positive square root of 3 for every single term that will ever exist. So that would be our answers for the positive. And so now with the negative, we look at, okay, first of all, where's the first positive one that we have on our chart? The tangent's a negative square root of 3. What radian measurement? Now this one, that would be 2 pi over 3. And once again, just like it was for this one, if we add pi to that, that would give us the next one. Then we add pi again, gives the next one. Pi again, gives the next one. So we're going to write this as, instead of it being pi over 3 for this is going to be pi over, the 2 pi over 3 plus pi k. And k is an integer. So that's for every single value. Every value that would ever possibly happen. So once we get down to our answers here for tangent, for the square root of 3 and the negative square root of 3, look at where's the first positive one that we would have square root of 3. Then look at where the next one would be, where the next one would be. And we'll look at, okay, how do we get from the positive pi over 3 to the next one that's going to be the answer of square root of 3? Then how do we get from there to the next one? Then there to the next one. And it should be a pattern that's forming. And so here, that would be pi over 3 plus pi k. Then the same thing would happen here with the 2 pi over 3. Look at where does it start first? Where would that tangent x be a negative square root of 3? Where would first be positive radian measurement? And that's at 2 pi over 3. And then we look at the next one where that would be. And we'll see from 2 pi over 3 to that next one, where would that, what we have to add to it? In this case, once again, it's pi. So we do 2 pi over 3 plus pi k gives us the next one. So if it was If we added pi over 3 to get the next one, then we're going to have 2 pi over 3 plus pi over 3, k, and k will be an integer. But you have to figure out how to get from the first one to the second one, whatever interval or amount of radians that would be, we would add that to the next one, next one, and that would give us our answers for these. All right? All right, see ya.